So, where's our chat? So this is called. I'm gonna share this with you. It's called Code Share.
Okay.
Um, basically, it allows us. It's like the other thing, but you can't run stuff. But now that we have your thing set up, it's okay.
Okay.
So what you'll have to do is just copy and paste this code, and put it in yours, and just run it. So why don't you make like a new project or file? Just call it like lesson 2 or something.
In PyCharm?
Yeah.
Okay. So when it says new environment, I want to use virtual env. Does that sound right?
Can you share your screen actually?
Yeah.
Um. Yeah. Here, keep your stream up. I'll just like watch you as you do your thing.
Oh, sure.
So I can help.
It would automatically close. Dude. Okay.
All you need to see from me is the code share though. Interesting. I don't use PyCharm anymore, but yeah, I think it should work.
Okay, and then I need to do. Oh, dude, I just did this. I just figured it out. I need to
Mm-hmm.
add configuration, right? No, that's fuck. How did I do this?
I think it's file up top, file new scratch file. What is that? Try that. Python. Oh, that's a scratch though. What the fuck?
Oh,
Hold up. What the hell?
wait.
Hold up. Go back to the lesson 2 folder. Just click on the folder right there. Yeah. Now do file, new, Python file. Yep. And just call it like lesson 2 or something. There you go.
Sure.
Yep.
Then
See if that runs with the play button. So right click on the tab real quick. And just click run lesson 2. Interesting. Oh, I think I just saw it. Go back to Python console. Oh, this is so weird. Just click play in the right top hand corner then. I guess that's how you run it on this.
should I just use what you use so we can?
Sure. So go to your like web browser and just like look up Python idle. So it's spelled like this.
Okay. That is. Is there a particular website you would recommend?
It should be from the Python website.
Oh, okay. Okay. They just can't make anything easy to find.
Yeah, I could probably get it for you.
Thank you.
Actually, you might actually have it. Can you search on your computer Python idle?
Yeah.
It might auto install with Python.
Like I have Python 3.7, but not anything called idle. I have that like terminal looking thing.
So if you search IDLE, nothing comes up.
Oh.
Yeah, click that one. Well, it says like 3.7.
It says, can you still see my screen?
I just see your. I just see
Okay, hold on.
whatever that is.
Let me access so you can see what I'm. Is this what I'm supposed to be?
Yep. So go to File, New.
Or
Now.
file, new file.
Yep.
Okay.
And just name it. Did it bring up a new thing called Untitled or something?
Yeah, I brought up an untitled.
Can I see that?
Oh god damn it! Yeah. Is there a way to just like share my desktop? Oh, screens. Duh. Fuck. All right. There we go.
There we go. Perfect. So now click Run.
Run module.
Yep. You can just save it as whatever you want, wherever you want. There you go.
Boom. Okay.
Nice. You were fucking lucky your computer didn't shit itself when you installed Python.
Why would this have not worked?
We have to do some weird stuff to like fix it. Mine, like when I installed it, it blew up. Cool. So
Okay.
anytime you want to run it, that's how you run it on that. It's just like a basic way to start learning Python without like all the weird virtual environments in PyCharm. Um, Eventually, when your projects get big, you're going to want to move to something like PyCharm.
Okay.
But for now, we should be good. So let's move on to lesson 2 on cakes.
Sweet.
Okay, so you can see the code share and stuff.
Code. Here. Yes.
So I'm gonna write something. This stands for ingredient. Ingredient 1. So what's one ingredient we'd add to a cake?
Eggs.
Eggs. Cool. What's another ingredient?
Sugar.
Sugar. Nice. IDG 3. We'll do 4 ingredients.
Okay. Let's just say milk, but I don't think that's right.
Sure, we'll put milk.
Hannah, did you put milk in cakes? Okay, no, that was a no.
Alright, fuck. Was it flour or something?
Yeah, flour, sure.
Flour and cocoa
Sure.
powder. All right, so now before we create a cake, you and I need to, put all this shit into a bowl. Otherwise, we don't have a cake. So, here's a bowl. It looks like that. Right? So,
Okay.
let's print our bowl real quick. Let's see what it does. I'll let you do that in your thing.
Okay.
Oops. Other tab.
Ah. Should I just delete this and re-paste?
Yep.
Oh. Run, duh. Okay.
There you go.
All sources.
See, we have an empty
Oh.
bowl. See that?
Yeah.
Okay, so we have a bowl, and we need to add our ingredients to the bowl. So one way we'll do that is we can say, all right, let me put that in. So I think it's bowl.append ig1 for the first one, right? So let's, I guess we'll have, do that. So you can go ahead and write that into your file if you want. So it's bowl.append, and then whatever you want to put in. I think I wrote that right. It's not dot add. Yep, okay, good. That's right.
Then run it.
You can print your bowl after it too, just to see what it looks like.
Oh.
There you go. You might have spelled it wrong in the append.
Do I need to capitalize?
Yep.
So is that important? I like if I don't capitalize, it'll.
Yeah, case sensitive. So whatever you name it,
Okay.
it doesn't matter. It's just, cool. So you added the second ingredient. So now you have sugar.
Okay.
So why don't you go ahead and add all 4? I'll do the same thing. And then
do I add it all into the same append thing, or do I have to make individual?
The same thing. So you do append IG2, IG3, and IG4.
Okay.
And then print that. And we'll see what it does. Oops. I completely forgot to teach you this yesterday.
This is like super important.
Yeah. I was like, man, I taught him everything that he might need to know for like basics. And I was like, oh wait, I just missed like 30 topics. I wonder if anyone's watching right now.
Are we live again?
Yeah. Let's see. My friend says make him build a settings page.
What does that mean?
When he was teaching me how to build like apps, I was on the task of building a settings page, and it took fucking months. it was something else. Cool. So everything got added. This is called a list. When you put those 2 square brackets, anytime you want to group stuff together in like a cool way, you call it a list. So that allows you to like put stuff. You can think of it like a backpack too. It allows you to like put a bunch of shit in there and then transport it around. So what if we want to figure out, so we're going to go back to the for loop. Actually, so this is a cool thing. So if you want to figure out how many items are inside of your bowl, right? You can do length of bowl like that. So if you do that, it'll tell you should expect it to say 4.
Okay, so I typed that in. Does it matter where it's?
You can do whatever you want.
Okay.
There you
Okay.
go. So 4 items. So that's really useful. So what if I want to? So what if I want to figure out what's the first item we added into our list? So what I can do is I can do bowl of 0. Oh shit. Let's try to make me sign in. So if I were to write this, fuck. what it did? I pressed insert. Actually, we'll do, yeah, bowl of 0. So if I were to print that, what do you think would come out? If you don't know, you can always just put it in your code and see.
Oh, okay. Invalid syntax. What did I do wrong? Oh, didn't do the right brackets.
Yeah. There you go. Eggs. So if you were to change that to 1, what do you think would come out next?
Would it be sugar?
Yep. So the way it works actually in like any language, I'm pretty sure, is the first thing in your list will have an index of 0. So you always start at 0.
Okay.
So it's 0, 1, 2, 3. So what if we wanted to access every single thing in the list, but we wanted to have a reduced version of the code, like a smaller. Now we did this the last lesson. So what do you think? What do you think we could use?
Would it be? Oh, it's like the a greater than equal sign 3. Is that kind of? Hold on, it would be.
Yeah, you can write it in the code share too if you want.
Okay, let me see if I can.
So basically, we want to print everything in the list, but with like 3 to 4 lines of code. Well, okay. I mean, we don't want to write anything more than once.
Could it be? Is it? Like that?
Where'd you write it?
26. I think there's a delay between.
Oh, what the fuck? Oh. Kinda. You're getting there. There is a way to do it like that. Honestly forgot, but I'll give you a hint.
Okay.
Does that ring any bells?
4. No.
What that?
Four.
Here, I'll set it up for you, and then
Okay. Oh, okay.
So what number right here do you think we should go up to? So what it does is it doesn't have the last number. It'll count and stop when it gets to that number. So, yep. Actually, one more.
Oh, it would be 4.
Yep, because it stops at 4.
Okay, so if it still gets indexed at 3, but it still counts as number 4, is that what that?
So what it's gonna do, we can actually, if you want, we can print out I. So you put that in, you'll see where it counts to, and it'll make sense. So you can just run that. What the fuck?
I think it just ran.
Oh wait, never mind. Sorry, you called it Oh, I thought that says cocoa. It's small. I thought it said 000 powder. I was like, what the fuck happened? Cool. Did you see how that works? So it goes 0, 1, 2, 3.
Okay, yeah.
Yep. If you want to be really good, you could do, instead of 4, you could put length of bowl. So that you're going to do this like a lot. So I would do it that way, because just in case you want to add more stuff to your list, it'll change.
Okay.
So
Okay,
yeah.
word.
So those are lists. You could also, so let's say you want to do numbers or something. So numbers equals, you could also just put them in like that when you start your list at first. 2, 3, 4, 5. So that you can put numbers in there. So that'll just like print out that list of numbers. So that's one thing you could do. You could put all sorts of things in there. You just got to make sure they're all the same type. If that makes sense.
Okay.
So like you can only put, I think you can only put integers with integers and strings with strings. I mean, we can always test it. So let's see what happens if we put a string. Will it explode? Maybe. It won't hurt your computer. Oh, you can, apparently you can do that. I actually didn't know you could do that. Cool. That's really fancy. You could put strings inside of strings with numbers. All right, so now if we had like a bunch of numbers in there, and we're like, all right, shit, that's ugly. How do I sort that? Now I could teach you like a crazy algorithm to do that, but that's not important right now. I think
Okay.
it's sort numbers. I think it's numbers.sort. Yeah, it's numbers.sort. I think it's numbers.sort. Yeah, so numbers.sort. So if you were to do that, I'm pretty sure it would work. You can check that if you want.
Sure, yeah.
Oh, okay, cool. You're gonna see something interesting. It kind of did what I wanted it to do, but also didn't. But it's a cool lesson, I guess.
Okay. Let's see.
It says none.
Yeah.
So now, underneath that, I want you to write print numbers.
Okay. Oh, wow.
So it sorted them there. So numbers.sort, that's a type of so remember how you and I defined our own function before? Where we said def, like we went like this. We were like def function name something like that.
Oh, like it was like add something, I think.
Yeah, and we're like print whatever. So when you and I did it, we wrote return like something. We had it return something. So if you were to print the function after you called it, it would give you a response. But if we got rid of that, you would get something like none, which means that it just did stuff internally to the function. But like it's not going to give you an answer. Does that make sense?
Yeah.
So there's another way. So if you wanted it to give you an answer, you would do numbers dot sorted. I think it's that. Let me see. Hold on. Let me check that before you do it.
Okay.
I forget. Fuck. Hold on. Let me look it up. Sorted Python. You can run it if you want. What I had. It's gonna blow up. Okay. I remember now. Here you go. list does not have attribute. Do I have to import this shit? Oh, it's a tuple. What the fuck? Hold up. Sort list Python. Dot sort. Okay, I guess there's no function, whatever. But I'm going to show you an example of bubble sort in Python. So this is what might go beyond under the hood. So of course, you and I, well, this function that I just showed you does something else. But like, if you wanted to sort something, the algorithm to do that, or the function, holy fuck, looks like this. Let me just clean it up.
Okay.
So you see that? It's called bubble sort.
Yes.
If you're interested, you can look up on YouTube bubble sort for how it works. But if you were to call bubble sort and we put in our numbers like that. Oh, actually, that's wrong. So this one doesn't return an array, right? So you would just call bubble sort numbers. And then print numbers. So if you were to like run that, it should just sort your numbers for you.
Okay, let me see.
Yep, should.
We'll sort. Oh. What did I do?
Oh, go back to the code share. It's different.
Oh, it's different?
Yeah, it might have just updated.
Oh, shoot. Okay.
It's that whole thing I just pasted in.
Oh.
So it looks scary, but you don't need to know what it does right now. There you go. Yep, so it sorts your list for you. Or I don't think you called it, but yeah. But if you were to like call bubble sort, it would sort your list.
Oh yeah, I forgot to put that last bit in here.
It's cool. I mean, if you want, I could. This is like the type of stuff you do on a whiteboard to explain how it works.
Okay.
This
There it
one's
goes.
not particularly complicated. But if you were to have a really long list, it would just be too resource intensive on your computer. That's why they don't use it. That's like you're getting into the math type of stuff, but that's what like a sorting function might look like. There's all sorts of sorting functions. So there's like merge sort. There's bubble sort, obviously. There's quick sort. Insertion sort. So if you want to look those up, you can later.
Yeah, sure.
There's like cool animations online.
Why would you use this over the other sort, the print numbers dot sort?
So, well, actually, you wouldn't. Usually, what happens is Python already has one. I think they use radix sort or something that's already built in. Usually, they introduce you to like sorting methods as like a easy way to understand algorithms. So like an algorithm's a way to like solve a bunch of problems and like stuff like that.
Okay.
So that's why they introduce it. It's cool to look at. So like definitely watch like an animation on how to do that when you're free. So yeah, so I guess that's it for lists, or like the basic stuff in lists. So now that you understand lists, we're going to move on to some like strings. So strings actually have a lot of stuff that you can do with them. So I'm going to define two things. So I just wrote something. I don't know if you could see the whole thing.
Yeah, I can. So do you always have to put a space after like the equal sign and before them, or is that
No,
not?
no, you actually
Okay.
don't. I do it because it just looks cleaner.
Oh, okay.
You'll develop your own styles over time, though.
Well, it's gonna be probably pretty similar to what yours is.
Fair, fair. So before you run C or print C, what do you think? Just basically using your intuition, what do you think is going to happen?
Um, it's gonna print out the algorithm A plus B and turn it into a full sentence, or the full phrase. My name is Zach.
Yeah, yeah, pretty much. Try it. So that's cool, right?
Yeah.
So that's called string concatenation when you add two strings together.
What's it called again?
Concatenation. I think it's spelled something like that. I wrote it in the code share. I think that's.
Oh,
I'm terrible at spelling, but.
okay. Yeah, me too.
But if you're ever like, huh, how did you get to some problem and you're like, oh shit, I need to add these or combine these two strings. How do I do that? So you look up, how do I do string concatenation? Or you might start learning stuff in C. You're like, oh shit, it's different in C than Python. String concatenation C, and then someone will give you the answer somewhere, which is cool.
Oh, okay.
Okay, so of we'll make a new one. Okay. I think this is correct. I gotta remember. I'm like, let me just check that real quick before I give you fake code. Okay, cool, cool, cool. So the lines I just wrote, so it says D equals 5.
Uh-huh.
Print length of D. What do you think that'll do based on what we did previously in the list section?
Will it just print the single just with D is? Is that what it will do?
Length of
So
D. You can
I
try
do
it.
not. Yeah, I guess I'll have to look. Oh, what did I do wrong?
Forgot probably a.
Oh, 2 print.
Yep. There you go. 4.
Oh, okay. Yeah, I had no idea what that was gonna do.
So if you're like, if someone gives you, all right, so let me get a really long word. Longest word in the English language. Okay, so some motherfucker is just like, all right, Eric, I need you. I'm gonna give you a bunch of words. I need you to figure out, what are we on? E equals this. Someone's like, all right, Eric, how many letters are in this word? And you're like, all right, you're like, I'm not counting that shit. I'm gonna make mistakes. You're like, all right, print length of E. So you run that,
Oh,
and you're like, there you go. That's how many letters are in that word. 22.
okay.
Cool, right?
Yeah, that is cool actually. Oh, what did I screw up? Oh, I'm dumb.
There you
It's like a big issue, like misclicks and like that messes you up.
go. A lot, yeah. Oh, look.
Okay.
John's in here just listening. What's up, John? I think he's watching you. Cool, right?
Yeah.
I don't know what that word means. That's a real word.
Orth. Oh, I would guess it's some kind of study of bones. No, that's ortho. Never mind. I don't know. I won't even try.
Okay, so yeah, that's some string stuff. So I think Let me test this real quick on my end, real quick.
So if you did like a sentence, it would still calculate out the number of digits of letters or whatever. Would it also count spaces?
Try
I
it.
guess I could.
See what happens. I'm just testing something that I'm going to show you in a minute.
Okay, that didn't help. All right, well now I gotta. Okay, so it does count spaces.
Yep. So a space is actually a character.
Okay.
There's a thing called. I'll show you it. It's kind of interesting. I'll paste it in our thing. So this is called the ASCII characters. So every character you have, I actually don't know if our computers still use ASCII. I think they use something else. But basically, all these characters have a numerical value associated with them. So yeah. So even space, it's number 32.
Two.
Cool.
Oh, okay.
So another cool thing you could do is this. So we have this long ass word, and yeah. So based on the list stuff, what do you think that'll do?
It will.
Let me pull up your screen.
Oh man. It'll print out. Will print out every single letter.
Yes, dude. Yes, you're getting it. There you go.
Whoa.
Hell yeah.
Okay, cool.
Yeah, man. Oh, I just figured out what we could do, which is gonna be interesting. You'll find it cool.
Oh, cool. Okay,
Yeah, isn't that cool, right? All right,
Yeah,
cool.
yeah, yeah.
So now we're gonna take it a step further, and we're like, okay, well now I got this very strange word. So now I want to do some like cool math on it. So I'm gonna say my word equals a list, and now you're gonna, instead of printing, you're like, all right, let's pop all these. Let's put all of these words into this like little backpack. So you're like, all right, cool, let's do that. Try that.
All right.
Oops.
Line 7. Oh.
Cool, right?
Oh, so what does that mean when it does it like this?
We put all of those, like every single letter in that string, or every character, we put inside of a list. And so now we have, instead of having it as a string, we have it as a list. So I think we're about to do something really cool.
Okay. Okay, I understand.
You might see what I'm about to do. Let me just. I think we could do this. I'm not sure. Fuck. Did I do it in here? Fuck it. I'll just use Bubble Sort. Oh no, we can't do that. I'll look it up. Sorry. Hmm. Okay. Yeah. So that should work.
And so when you're making a list, it's just to kind of make it easier to look at something that you've put in the code doesn't like serve any functional purpose other than that.
Um, for now, we're kind of at a point where you and I are just like looking at it
Okay,
because it's like
okay.
cool, but there are some really cool functional purposes. Um, I can get into that soon. We gotta,
Okay, cool.
we'll get there soon. All right.
Yeah, sure,
So
sure.
now, Eric, I want you to alphabetically sort all the letters in that list.
Alphabetically sort.
It should be only one line of code.
Okay. Um. Okay. Let me see.
And don't use bubble sort because that'll blow up.
Okay,
That's
don't
not
use-
prepared for this. You can try it and see what happens, but I think it'll explode.
I will try.
Actually, yeah, try it because I'm curious too.
Okay, okay. I don't really know how this works. Can't wait. I need to change.
Oh, you could. So basically, the way bubble sort works is you just write bubble sort. So scroll down, just to where you're writing. If you want to use a function, like all the way to the bottom,
Oh, of down here.
wherever you were writing code. Oh, I see. Are you trying to rewrite bubble?
Yeah.
Yeah, so you can get rid of that and just do bubble sort, type bubble sort. I think it's capital S.
Of course it is.
And then just pop in my word. Highly
Okay.
likely it'll explode, but nothing bad will happen. And then just put
Okay.
in my word, yeah. Or the list.
Oh, the list.
You see where we wrote? You just write my word because we already defined it.
Oh.
Yeah,
I forget it's smarter than me.
yeah. And then I guess it didn't crash. All right, then print my word underneath bubble sort and see what it looks like. There you go. Wow. Okay. Did it sort it?
Yeah, it did.
What the fuck? Wow. I did. Oh wait, it kinda did.
Wait, A C
Oh
G
no, it didn't. Shit.
I L L N O. Yeah, is that not alphabetical?
It says A. Is that C?
Yeah.
Oh, I thought that was an O. A C G G. Yeah. Cool. Well, I guess that
So,
worked.
so it has an automatic feature to sort the alphabet as well, I'm assuming.
Wait, remember how I showed you that like table of things that's called like ASCII characters?
Yeah.
So what it does is
Oh,
they're each associated with like a number in your like computer's memory. So it's comparing those numbers, I'm pretty sure.
okay. Oh.
Yeah.
Okay. So it knows the alphabet by its number and sorts the numbers, but I don't see that.
Yeah. So like
Okay.
actually I can just show you. So remember how we did yesterday, we did print type of something or like a number and it's popped out like integer and it was in that weird like form.
Yes.
So what that is, we're gonna get into that soon, maybe like tomorrow or something, but that's basically called like an object. So really, so in binary, this is one. So that's a binary for one. This is binary for two. That's three. That's four. So So like this, 1, 2, 3, 4. So it doesn't actually look like that. It's a little more complicated than that. But basically that's really what it looks like. So that's how the computer understands it.
Okay. Okay.
So yeah, so that's probably how it compared them as letters. So like letters are associated with these as well. They have their own numbers associated with them. So like
Gotcha.
32.
Gotcha.
32 is what is 32? 32 is space.
Space bar.
Yeah. And then like A is 65. Lowercase a is 97.
Okay.
So it's like if you're interested one day and you're like, man, what is my computer doing? That's what it's doing. Just a bunch of
Okay.
additions and stuff. Cool. So now we're like, okay. So your next task is like how many letters appear in each of or how many of each letter appear in this strange word? That's what they want to know for some reason. So you're like, okay. Well, I could go in and count, but that's kind of we're not going to do that because that's not fun. So we're going to create an algorithm called count letters, right? So we're going to pass in we'll say this is X is our list, right?
Yeah, let me see. I gotta wait for it to jump up at me.
Actually, hold up. We're introducing a new concept called a dictionary. We're going to use that for this function. So I'll write this and we'll go over it together. So I'm going to say for every letter in X, we're going to call frequencies. Is that? Actually, no. We'll do it like that for now. If letter not in frequencies of letter equals 1, else letter, frequencies return frequencies. So print count letters of my word. Let me check that on my screen real quick. I definitely fucked something up. Oh, dude. Fucking first try. Bet. Okay. Yeah. So you saw something I added there. A couple of things I added there, which we've never talked about before. But I'm sure you're going to see, once you run that and like play with it, you're going to see what that does.
Oh, what I do wrong? Else. Is that to be?
So I think your print statement is in your function. So if you like, so anything that's like indented under a line is like engulfed by that function. So you just press.
Oh,
So where printed, well yeah, those two. But where you printed, just backspace it. So you want your return outside of the for loop.
oh, out there.
Yep. And then frequencies needs to be also indented. Just yeah, there you go. Actually,
Or
tab it under the else statement. Yep, one more. There you go. That one's like fucked up the return. So go to return, backspace once. There you go. That should work. I think that was a space.
maybe I should have just copy and pasted.
I think you just spelled it as it's count letters. That's why.
Okay. Oh,
Frequencies equals dict, which is DICT. Up top. Yep.
oh, okay.
And then yep, and then another yep. That works.
Oh, there it is. Cool, cool.
So you see, we can now I can ask you, how many times does A show up? Clearly 2.
Twice. Yeah.
How many times does O show up? 5.
5. Yeah.
So that the thing you're looking at is called a dictionary. Whether it's related to like the word dictionary, I actually have no idea. But yeah, so it looks like this. This is what so you have your like A to 2 or something. We'll just call this test. So that's what it looks like if you want to hard code it in. Test. So I guess you could run that if you want. Yeah, just says that.
Is it 83 that you just put in? No. Oh, there it is.
82 and 83.
So slow.
I know. I think it's because like I'm not logged in.
Oh,
So
and
they're
they
like they're
throttle
trying
you.
to, yeah, they're trying to cuck me.
Test.
Wonder if anyone's watching actually.
A2. So what did this do?
Let me see. Oh, we just like defined a dictionary. So like that's another way of defining a dictionary. So you basically
Okay, so is that okay, sorry.
So if you wanted to, so our count letters thing, let's get rid of the print statement around it. We'll just call it F equals that. And if we wanted to get, let's say the frequencies of, we'll say O, because O has 5. This is how we do it. That. Did it show up?
Were you typing in 77?
I'm on 85. Fuck,
No,
is
it didn't show up. So slow.
Oh, they're gonna make me log in. Fuck it. I'll just like, can I share my screen?
Probably.
Let's see how well my computer handles this.
Streaming and live stream.
Yeah.
I guess both are live streaming.
Could I not do my screen? Where is it? Oh, it's not intuitive. Screen 1. Alright, you could just like watch my screen, I guess. It's probably so
Okay.
much better, to be honest.
Oh, it nicked my stream. Okay.
So this is what I typed.
Okay.
So you're like, alright, how many frequencies are associated with this or whatever?
So okay.
Or how many, how many O's show up in our crazy word?
What's wrong, computer?
What error is it giving you?
It's just making noise at me when I click what's it called? The bracket.
Oh,
It gave me line 88 print is not defined. Oh, I forgot to define F.
yes, sir.
Equal. Okay, and it came up with 5.
Yep.
Cool.
So that's interesting, right?
Yeah, I can isolate each.
Mm-hmm.
Okay, okay.
So you said you were interested in cybersecurity.
Yeah.
This is related to something called a Huffman tree, which is a way of like encrypting. Um, it's a way of encrypting things based on like, so like your key basically is like a paragraph of text, and then you use it to basically encode messages based on frequencies of words. So like, I'll paste it in chat. We're basically doing this like the frequency collection before you create the Huffman tree. Um, it's interesting.
Okay.
There's like pictures of it. It looks like this. It's like a tree, but it's a really hard problem it made us do. Um, maybe we can work on it, but it's a little scary.
Okay.
Um, but it's actually not too crazy. So that's a Huffman tree.
Oh, cool. Okay, that's pretty neat.
So there's all sorts of cool stuff you can do with that. Um, you could do this like collect frequencies of like sometimes maybe you'll get a string of like DNA, and then you could like be like, all right, let's count the frequencies of like the different I don't know strings in the frequency, whatever they're called, the different
The
patterns.
machiggers.
Yeah, the
Yeah.
majiggers. We did something called suffix tree. Yeah, that's another related one. What's it called? The suffix tree. So like, uh, I'll send you a picture of the suffix tree. So you basically like break up the word banana into like stuff like that. Yeah, here's like the one for DNA. Yeah, it's scary, but you know, something you can look at in the future just for motivation on why that's important. So
So
yeah,
what does this all mean? Like these suffix trees?
so let's say you're given a word like race car, for instance. Um, Notice how you can like spell it forwards and backwards.
Hmm?
If you wanted to figure out how many times like a phrase repeats, so like in our case for like the DNA thing, you want to figure out how many times a sequence in a DNA appears. You can basically build this tree, and then you can use that tree to get the answer. Um, so these are all like okay. So the two suffix trees are like not really related to the Hoffman tree, like the
Okay.
two ones on the bottom. But the Hoffman tree, basically what you do is you create a tree with all these frequencies, and I think you sort it in a specific way, and then depending on which direction you go down, I think if you go left down the tree, it's a 0. If you go right down a tree, it's a 1. So then you use that to like encrypt your message in binary. So like if you wanted to get an A, so in our case A would be left and then right and then left on that tree. Do you see that? How you go down,
Yeah.
you go from 36 to 16 to 8 to A. Yeah, so that's like 0, 1, 0 would be A, if we're doing it that way. And so you get this like crazy sequence over the internet, and it's basically secure because unless they have like the text file or something that you use to encode that, they're going to have no idea how to encrypt it unless they're like really good or something. So that's like basic encryption stuff. Um,
Wow.
yeah, so it's cool. Maybe we'll write a program sometime this week about like encrypting like
Oh, that'd be
secret
cool.
messages. It'd be cool, yeah. Um, I'll have to like pull up old things. Like what we can do is you can read in like a book, like an ebook, and then yeah. And so you need the ebook in order to decipher the message that we have. So you could use like oh yeah. So one of our problems we had was we used Game of Thrones. They gave us that book, and we had to use that text in order to. Actually, I think we compressed it, or we like compressed the book using a Huffman tree. So like you got this weird ass file with all these weird characters in it, and then you could decrypt it and decompress it. So it was like less space.
Oh, wow. That's crazy.
Yeah, it's cool stuff. Coding it, sometimes you want to like smash your head into the fucking like computer, but it's cool stuff. Um, oh yeah, so I guess I didn't like explain count letters line by line, but we'll do that real quick.
Okay.
So frequencies. This is how you create a dictionary. So this thing test right here. That's basically what we're creating. We're basically just creating this thing. So it's empty. There's nothing in it. Does that make sense?
Hmm.
So for letter in X, this is a new line that you haven't seen yet. So it's basically going to say for every letter in X, we're going to run this. So first it's going to run A, then it's going to do A again, then C, then G, then G. Right? So you can actually
Yeah,
write
yeah.
in like hello. So you can see that in action right here. I'll run it for you.
Sweet.
See, so go through one letter at a time. So that's if you don't want to use this, you can do it like that.
Okay.
So these are like basically equivalent. This one's just easier if you're going to be doing other like math stuff. Um, so yeah, it really depends. So if letter not in frequencies, that's saying if our letter, our key, so every string becomes a key. See how we popped this in here? Your key
Yeah.
in this case is 0. And the information you're going to get from popping that in is 5. So here's a key. So if our key does not exist, if we haven't written it to frequencies yet, we're going to do this line. Does that make sense?
Yes.
Okay. So frequencies of letter. So now we're defining that key. We're like putting it in here. We're going to set that to 1 because that's the first letter we found. So if we start off with A, we're going to have A. We're going to check it to count letters, or check it if it's in frequencies. Sorry. If it's not in frequencies, we're going to go here and we're going to say, okay, the key A for now equals 1. Otherwise, if it already exists in there, we're going to add 1 because we found another letter that's already in that dictionary. Does that make sense?
Uh, kind of.
Here, let's go into the whiteboard real quick.
Sure.
So let's say we have the word hello. So the first thing our algorithm is going to do is it's going to take, H. So here's our dictionary. Looks like that. It's empty. There's nothing in it, right? If we printed it, it would just look like that. So we check H. So step 1, we take out H. So that's that 4 part, 4 letter. So we're like, all right, H. Is H in here? No, it's not. So we're going to take H. We're going to add it to our dictionary here. H equals 1. So 2 or 3. We're going to make this hello. That's a new word I just invented. Okay, so next we're going to move on to E because this is done. So you go back up to the top when you're done. So E. Is E in here? No. So E equals 1. That's done. So now we have L. Is L in here? Nope. So we add it in there, right? So now we have a new case. So L's already in here. So we go to the next L. Is L in here? Yes, L's in there. So instead of 1, we're going to add 1. It's L.
Okay.
That becomes 2. So this goes away. So our new dictionary looks like this. Equals 1. E equals 1. L equals 2. Right?
Okay.
So now we're on the last H. Is H in this dictionary?
Yep.
Yeah, it is. So what are we going to do?
Just add 1 to it.
Yep. So now our new dictionary looks like. Fuck it. There you go. That you know what that says.
Yeah, I understand the concept. Okay.
So does that all make sense on how he did that from the algorithm in the whiteboard? Just the basic intuition on how it works.
I think so. So if it, but like, so the computer does that automatically behind like that dictionary sorting, right? Of how many H's and E's are in there.
Yeah, so we told it to do that.
Okay.
So so this line right here. Can you explain what this line does to me? The one I highlighted.
Okay. So if it's not in the dictionary,
Mhm.
add 1 to it,
Not
or
yet.
put it in as 1. Oh no.
So just this line. So what is this? Like, what are we asking the computer for? Actually,
see
no.
if it's
Yeah.
okay.
Yeah, this line first.
So to see if it's in the dictionary.
Yes.
Okay.
And so if it's in the dictionary, what are we going to do?
We add 1, or we give it a 1. You
Yep.
put it in once, right?
Yep. So the fancy way to say that, you basically say we initialize it to 1.
Okay.
It's very it's very nerdy, but
It's very technical.
So what happens if the letter or our key is in the dictionary? So what if we hit that second L?
Then we initialize it to 2.
Well, it's already initialized, so we just add 2.
Oh, okay.
So initializing is when you make that first value before you change it.
Okay. Then it's adding.
Yep.
Okay.
And then what does this line do?
Continue to the next one.
Well, basically, it's gonna give you the answer. So it's gonna say, so when we do this equals thing, this whole thing equals frequencies. So it gives you that. So F, whatever you return is what this is going to be equal to. Does that make sense, or is it?
So that would mean it would count and so the count letters that f equals would count the number of times it appeared in the dictionary and print it, right?
Yeah. So count letters. The whole thing does like all that magic we saw.
Hmm.
Um, but if you want to give the person who's using this function the answer, you need to say return frequencies. So by doing equals, because remember how um, we had that sort that said none when you tried to sort it?
Yeah.
Yeah, so if I got rid of this, it would give you none because nothing was returned. But if I do that and I print count letters my word, it would print out the dictionary.
Okay.
Yep.
Okay. Okay.
So like if you want to give the person using it information, you say return. If you want to just like do a bunch of stuff and not tell them anything, you leave out the return. So it
Okay.
all,
So if you
yeah,
take the return out, it still does the process, but doesn't show it to you.
yep,
Okay. Okay.
100%. So it really depends on what you're doing as you do this types of stuff. So yeah, so there's two ways you could do it.
Okay. Cool.
Cool, man. Um, we could talk about tuples, but like basically a tuple is just like it's like a list, but it's just two things, and it looks like that. So yeah, print L. So if you're interested, you could do that.
Okay. Let me give that a go.
Yeah.
Oh, it's just okay. Just prints out the list.
So if you want to check the type of that, like that, you can do that, and it'll say it's a tuple. Actually, these are very important. Yeah, see class tuple. These are important. So if you want to get the first one, obviously it's that. The second one is one. So it's basically like a list, but it's only two items. Um,
Oh, it's only two.
yep.
Okay. Print. What are these used for?
So remember the Huffman tree? We can basically use that. So if you look at the picture, do you see where it's like E4, A4?
Hmm.
Yeah, you can basically use it for that. So like, yeah, I don't use them that often. Um, I haven't used them in like 2 years, to be honest. But
Okay.
but like if you need them, you have it. This is like a bunch of tools I'm basically giving you for harder projects.
Okay.
Yeah. I think back to dictionaries real quick. I think if we did print count or printf dot keys, I think it's just that actually, because it's an attribute. I think if we ran that, it would just give us. Oh, okay. So cool. Do you see this weird shit it just printed?
Yes.
So basically, you see this weird number right here?
Yeah.
That is called an address. Um, imagine imagine your like hard drive is like a hotel, right? Um,
Mhm.
that's basically the room number of where the thing you wrote is.
Okay. And I can like search that in my computer somehow.
I think so. Definitely, you won't need to do that, but
Okay.
it's basically saying the function is defined at that space in memory. Um, yeah, so that's like cool stuff. So like, I mean, we could get into that weird shit later if you want, but but I fucked it up. So it's keys like that. So if we were to run that, it's gonna give me all the keys. So these are all the letters that show up in the dictionary, which is cool.
Let me see. Did I? Oh, okay.
Yep. Yeah. So cool stuff to play around with.
Alrighty, yeah, I got a lot more stuff to mess around with. Probably past the story one, but I'll still try to make it work.
Dude, you could do whatever you want. You don't have to make a text based. If you want to like try to build a Huffman tree, you can try. Um,
Okay.
we definitely have a lot more. You can definitely try it, but you have some more that'll help you build that eventually. Uh, yeah. So we still have to talk about classes, which I'd say it more has to do with the races in Skyrim. Um, you'll find that one interesting.
Okay.
Uh, we could start talking about like algorithms, like recursion. Um, here, how about I'll give you a quick demo of what like recursion is. Yep. So like, here you go. We'll paste that in. Oops. It's all my friends calling me. He wants to play COD, but I'm teaching. I'm teaching. So
It's lesson time, bitch.
the Fibonacci sequence. I don't know. Are you familiar with that?
Yeah, it's the pattern of like reproduction, like 1, 2. Yeah, yeah.
Yeah. So if we want to like write a program that like gives you them, you can. This is a recursive statement. You'll see it gives you what the fuck? Oh, it's saying the ninth digit in Fibonacci is 21. But notice how we call the function within itself. So it's like, you ever like pointed a camera at like a screen and that screen shows you what's on the camera? And it looks like infinity.
Yes.
It's basically like that.
What part of it is like that?
That you just keep reusing. You're just gonna keep going deeper and deeper and deeper. Like imagine you're going down this like infinite staircase. You grab something at the bottom, and then you run back up to the top. And
Oh, so it's
there's
gonna
your
keep
answer.
retrieving.
Yes, it's gonna keep going down, which you can see my hands. It's gonna keep going down and down and down and down. Um, yeah, well, you can go over that later. It's cool.
Okay. Cool, cool.
Yeah, so I think that's enough to chew on for today.
Yeah. Sweet. Thank you. Thank you.
Yeah, so definitely play with stuff.
Certainly
It's
will.
getting deep, right?
Yeah, there's a lot more to it now, and I think I understand most most of what we just talked about, which is good.
It definitely takes practice. So maybe I could give you some practice problems.
Sure.
Uh, hold on. Hold up. Let me grab this book real quick.
How you doing, Eric?
Oh, what's up, John?
I just cleaned my keyboard key by key because I'm so bored.
Is your keyboard nice and clean now?
Oh, it's so shiny now, but I'm eating Triscuits and cheese, so I'm really sure it's not gonna last long.
Oh, John. As long as you're not eating over it.
No.
Mine just has dust in
Alright.
it.
Alright, man. I got the intro book, so you could probably let me see if there's like a practice problem you could do.
Sweet. Breaking out the computer science 101 books, I guess.
Pretty much, yeah. No, it just gives you like a bunch of shit to do because like sometimes it's
Okay.
hard to be like I don't know what I want to do. I'll send you a picture of it.
Cool. You sending it over Snap or over Discord?
I was gonna text it to you.
Okay, cool.
Here you go. Enjoy. There you go. You can just do those. They're quick. You just oh, there's a thing called a generator function. Skip that. 'Cause I didn't teach you that. I don't understand that, to be honest.
Wait. Did you texted it to me?
Yeah. Are you
What number is in?
860 604?
That's my old number.
Oh shit. Well, this random
Here,
guy.
I have your number. I'll just text you.
Okay. This random guy is gonna be really confused.
Well, I think that number is deactivated.
Oh.
Well, I guess someone could have reactivated it. I guess I don't know. Okay.
New num. Bet. Alright, here you go. Oops. Yeah, these should be pretty easy, but they'll get your reps in.
Sweet. Dude, I keep getting this scam email that wants me to put in my PayPal